So recording, we are recording. So today is the day that you're gonna make, well, let's just start by actually from the example. So conjunction.
I wonder if it would make sense to add ifs to the language.
Ifs. Okay, I actually type it wrong. My bad. Branch. And now we will, just for the sake of it, we're gonna pull. And then we're gonna check out B conjunction. And now we can start to go. Okay, so let's start from the example. I want to start from this example, and then we just make it better. Okay, so what can we conjunctify in here? Okay. So this would be what? Plus 4 to out, right?
Right.
This is the example that we're looking for.
Yeah, that's gonna fail though.
Really? Why?
Oh no, it won't, because that's minus and that's plus. Okay, yeah, no, that should work.
Yeah, which puts a very good point that what happens if we can't unify? This is just gonna say segmentation fault, right? Right now.
Right now, it's gonna, yeah, because it's gonna loop
Man, we need to
forever.
at some point we need to take care of those things. Like we are doing such a good job on the compiler level, but the usability level it's completely ludicrous. Like we don't have any error handling at all.
Yeah, we don't. We also don't have a way to like, if a query has more than one answer, we currently only show the first one as well. That's not great.
I classify the error messages problem more important than that.
Hello, Mageta.
Hello, Mageta.
And what's on the book today?
Today we want to make this example work.
So minus one.
First of all, I don't think.
You
Hmm.
don't think?
Okay, so you just put a comma there, and
No,
should
we
that
can.
work?
Let's just start from that. What is the syntax for it? Nageta, did you get what is going on here?
Sorry, I just got distracted. Yeah, I think I do. So you're trying to match what number gives you the same output for an, the same results for
Plus and minus.
minus and minus.
Yeah, so let's just start from the syntactical point of view. So, Marinho, do you think comma makes sense? Like, I don't even think this is supported in Prolog, right?
It should be, but I'm not sure if that's the syntax for a normal query. Let me check that actually. Um, sweet prologue.
I actually didn't know you could do more than one query simultaneously in Prolog. I thought you would have to combine the two conditions in a separate new predicate.
I mean, you could, but
Actually, there is one way to implement it, isn't it?
hmm,
We could make an artificial predicate, like
called and. Yeah, that's an option.
like this, and then this gets converted quite literally to this. That is an option, isn't it?
That's an option, and that's very reminiscent of how tunneling works, actually.
Really?
Yeah,
Yeah, but this feels a little bit like cheating, though.
is it?
Yeah, because we are literally making the conjunction a syntax sugar for something else.
So you guys are debating whether you should do the conjunction at the top level or not?
No.
Another alternative would be, instead of making a fake query predicate, you just make an and predicate instead. But
I see. Well, okay, so let's explain to Mageta what we're discussing. Today is the day that we want to tackle conjunction. So that means that you have
Also,
multiple query.
okay, that doesn't. Okay, so the conjunction and disjunction doesn't exist yet, right?
Well, they exist on the level of
uh,
defining a predicate.
yeah.
They don't exist on the query
But not on
level,
the
though.
top level.
Yeah,
I
you
see.
cannot query two things being true at the same time. You are obligated to combine them, creating a new thing and asking that new thing yourself. And then what I just noticed is that if we want to be lazy, we can just make this syntax sugar for this.
I don't think that's lazy. That's actually quite smart.
Well, it is kind of lazy because we're not
Which
really
may be lazy,
tackling.
but
Yeah.
I mean, you're just reusing a mechanism that already exists, right? I
Exactly,
don't
but
see
I
the
don't
problem
know.
with that.
Oh, yeah, but how can I say this? Sometimes that's a very clever thing, and it makes like total sense. It's the most optimized route to make a feature. I'm not particularly certain this is the way in this case. Marin probably knows better than me.
This is probably okay actually.
Okay, but you were about to explain something different, right, Marinho? So explain your thing.
Like, just syntactically, there's also the option of implementing an and predicate, right?
Yes, so you mean like this, right? So this becomes this.
Yeah, and the and is not a real predicate, it gets compiled into an actual conjunction. The issue there is that because you're not explicitly saying what's the output variable, you kind of have to infer that. So that's more work than what you're proposing.
And I have another problem with your idea. This means that we're gonna have to. Isn't this a higher order predicate?
Kinda, but it's trivial to compile.
Mm. Okay, could you explain again the first problem with this approach?
You have to infer the output variable in this one.
What do you mean by infer? It is literally the only available. All the variables that appear here are the outputs, no?
Yes, but like you have to traverse the arguments of the end to figure that out, right?
No, but well,
And
but you're gonna have to do that anyway in the first approach as well.
but in the first approach, query is a real predicate. So actually, you only have to do whatever mechanism we can just reuse what we already have. In the case of the end, that's a bit more difficult because well, actually I don't know. Can we? We might be able to actually.
Mageta, which approach do you prefer?
I already said I'm fine with the first. The end doesn't sound bad too, but I do think it's more. Well, I don't know how you guys structure the code to say, but it sounds more.
Yeah, this is more work.
Yeah, it sounds like not only more work, but like harder. Like, what happens if you have another one there that is just an intermediary uh,
You mean like
predicate?
this, right?
Like if you have
So
three,
equal out.
Well, in this case, the end would not actually be a real predicate. It would
Yeah, this would be a
be
built-in. This would be a
a
built-in.
built-in, so it could be variadic, no problem.
I think that's a bad thing because that makes it less uniform. Because this is now has a special semantics. You cannot just read this as a normal predicate anymore. It looks high order and it's a built-in.
yeah, that's
Uh,
that's inconsistent. It's kind of fake as well. Uh, because you can't do this with normal predicates, can you?
Yeah,
Or is
no, we
you
can't.
can as a
no.
data structure, I think, right?
I mean,
Uh,
if you try to do this with a normal predicate, that's just a predicate with three functor arguments.
yeah,
Like
So
yeah,
yeah, it's just
okay,
data.
yeah,
mm-hmm.
which is what Magetta asked. Yes.
Yeah.
Yeah, so I think okay, I'm actually disliking this approach now in comparison to the first.
Yeah, I think the syntax sugar approach is the way to go,
I'm
actually.
very surprised that I was the one that could come up with it first. Okay, today is my day, folks.
Today is certainly not mine. I have stories to tell.
Okay, we
Oh.
can listen to them after the recording. Okay, so let's start then. So the first thing we gotta do is to allow this to be a okay. So we're gonna write this, right? This is gonna be the non-sugar version. Uh,
Can we also, besides allowing the comma, also say that, okay, if you have multiple question mark clauses in the body of the
oh, you
program,
mean like this?
yeah, that also gets added to the
Okay, but then I
conjunction.
have a question. Then
Okay.
I have a question. Let's say that I write this. Is this out the same as this out, or those are two different outs?
Logically, they should be the same if it's a conjunction, right?
Yeah, but I think that if you're not on using the comma, we should allow you to use the same variable name that is a different variable.
That would force us to implement alpha renaming, basically.
That makes total sense, and that sounds like a lot more work as well. Um,
Uh, well, for now, we can disallow having multiple question marks then and just use the comma syntax. That's actually probably better for readability as well, because the query is all in one place, right?
yeah, that was kind of my thought process because allowing it to be separate would like make it really hard to find. Okay, there is this query up here that somebody forgot 3 months ago, and there's this one down here, and because of the unification of the two, we are not understanding why the last one is failing. And that sounds a very like very bad experience.
Question, not directly towards this the conjunction or disjunction, but do you guys track a table of symbols of sorts where you put
Yeah,
all the atoms
We
in
do.
your?
yeah.
Uh,
It's called the functor
Not all
table.
the well, we have a functor table, but that's only for defined predicates. We haven't implemented an actual functor table for data structures
Yeah.
because we're not using a real bytecode, so we don't need that right now.
So we could actually do a LSP right now for it, right?
No, feel free. I'll support the idea.
Just asking, like, if you guys have that, it's possible, right?
No, of course. Um, and I
Interesting.
and I also want to propose this to be the we have the not named functor for arity 2. Let's introduce the non-named functor for arity 1. Well, this actually could be multiple arity, right?
Yeah, no. We have the blank name. Let's just call it blank. That's easier. We have the blank data structure, and that becomes that's basically
The
how our
list.
list gets desugared, right?
Yeah.
We don't actually have a blank predicate, and I think it's actually okay to just use the blank predicate for queries. Actually, that's nice because that means if you use a list syntax, well, no, actually that doesn't work.
Yeah. Yeah, that's very different. Okay, but we're gonna not disallow this type of stuff, right? We're not gonna be able to define the conjunction across the program. It needs to be with commas.
Yeah.
Okay. So this is the sugar, and this is actually the program. So let's start. Let's start by lexing, I guess. Do we need to change anything on the lexer level? I don't think so, right? We have already all the tokens. We only care about the comma, and we care about the query. So this is fine.
Yeah, this is totally
So this is
fine.
a parsing problem. So yeah, query here. So where is there it is. So I just need to allow this another thing which is similar to this thing, right?
Yeah, if you have a functor followed by a comma followed by hmm.
Um,
Okay, you need to have a separated non-empty list of functor elements, which are functors, and they are separated by commas. And that's the well, yeah, it's just functor with the two R's actually.
functor with two R's. No,
Yeah,
no.
that's the
Oh,
that's
that's
the
true.
name
That's true.
of
That's true. That's
the
true. That's true. That's true.
And actually, this can just be the
And this doesn't have the holds, so this is just
yeah
statements or queries,
yeah
I guess. The query token is the question mark, right? Query, yeah.
it is.
Okay. So now we just is this it, or am I dreaming here?
Uh, this is it. It's just hmm.
The conversion is wrong. This is wrong.
Yeah, no, the conversion is, yeah, no, as far as this parsing goes, this is it. The conversion is going to be a little bit tricky. We may
Yeah, we
actually,
have it here. Query conjunction. To do, actually make it multi-query.
let's just make it a list of yeah, let's just make it a list of functors, and then in the preprocessor, we can actually turn that into a single query followed by a declaration.
Sure. Sure, sure,
Or
sure,
vice
sure.
versa, the order doesn't actually matter.
Let's remove this to do. I don't remember. What is the difference between... Ah, the declaration has a head. We don't have that. Cool.
We don't have a head, yes.
Uh, okay, so what do we need to do? We need to do query. We did est query. Oh, this query.
Actually,
Oh,
we
there's no distinction. Oh, sorry, but in the query level, doesn't there is no distinction between clauses and parser clauses. It's already a parser clause from the parsing. We're gonna have to change that, right? Because now we need to go from clauses to parser clauses on the preprocessor.
Yeah, but that's actually we can keep that because the way we're gonna do it is we're going to keep doing just a single query, right? It's just that when we have more than one thing, we actually turn that into a declaration in the query, right?
Yeah, no, but my thing is that I think we should change this to also be a singleton.
Yeah, that should be a singleton, indeed. Like
Conjunction.
query conjunction and just make a
I
singleton
don't
list
remember. Is
with
this
the
how you do that?
it is.
Cool. And then this, we just make query conjunction. We don't need
And
any
then
of
it
this.
just
And just put the queries in
queries.
here.
Yeah.
Good stuff. Okay, so compiler assisted development. Dune. Oh, I need to change the example. So let's put conjunction. Dune exec Karuta. There we go. The preprocessor is the one exploding. This means that we parse it. We reached there. Awesome. Which is exactly the place we should go next. So now the queries, they don't have it. They don't work like this anymore. So we're receiving a parser clause. Wait, but where is this being called? Unreachable group. I think it's something like this. Um, actually, parser to compiler. Where are we calling this? We're calling this in the compiler? I don't
Uh,
remember. I actually
yeah,
start
you just
from main.
yeah, you just change the query in the thingy to get a list, right? So, hmm.
Group clauses. That's where we're going. LSP's fucked as always. Group clauses. Group. There we go.
For the sake of our sanity, we should probably forbid declarations with the empty name because that's going to conflict with how we desugar the queries, right?
Yeah. Now we should forbid that actually. But where should we do that check? Should we do it on the parser level or on the preprocessor level? We can make that in the
Uh,
preprocessor. No, we can make that in the parser as well. But that will
we
remove
could.
the non-syntax sugar version of lists as well.
No, because we just need to forbid the head of a declaration from having an empty name. We actually don't care about the arguments.
Ah, I see what you're saying, actually. So let's do that. So you go to parser, It's the functor, and it's the identifier, right? We just need to change this.
Ah, but if you change that, that gets used everywhere.
No, we're gonna have to make a new identifier that cannot be empty. We're gonna have to go
Um,
to, yeah,
Actually, I
here.
think normal identifiers already cannot be empty.
Oh, there, I don't see anything forbidding it.
No, it's up there. Let ident blah 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 lower letter. You see, the lower letter is mandatory.
Ah, okay, that's already the case then.
It's the problem is that we can also put an atom literal as a name, not just an ident.
But where is the atom literal? No, but an atom
Ah,
is an ident. It's a functor with arity 0.
no. In the parser, there's a difference between an ident, which is just a bare symbol, and an atom literal, which is single quoted. You
Literal
see?
atom. That cannot be empty. We need to change that. Literal
Ah, but if you
atom.
change this on this level, then you are actually forbidding the syntax sugar,
The non-syntax sugar.
the non-syntax sugar, yeah.
Okay, so
Which,
what do you think we should do?
uh,
But this is already forbidding that, right? This cannot be empty.
no, it can.
Oh, this needs to be this.
Yeah, that needs to be a plus instead.
It was already a plus. I think plus is 0 or greater. I think
No,
this
that's
is
the
1 or
opposite.
greater.
No, it's the opposite. The star is zero or more, and plus is one or more.
Ah, you're right.
If it's following the traditional syntax,
No,
right?
it is that. This is this because we already have the 1 being captured in here. Okay, so that's it. It was already forbidding it. Cool.
Wait, but hmm.
We can try to make an
Okay.
example to see if it fails. Let's see. What if I try to define this as this? Let's see if what happens if I try to run this program. Oh, actually that does work.
Yeah.
So the so we are wrong. This is actually still
Why?
allowing it.
Why does it work though? It really shouldn't. Uh,
What are we missing?
Literal atom. Then if you have one or more characters which are not single quotes, you just add them to the
Yeah,
buffer.
this is opening the single quotes.
Yeah.
This is erroring because this means that you haven't done the thing.
Yeah, you end the file without closing the single
Ah,
quote.
I know why. Okay, so here's how this is working. This is working the following way. If you parse the first quote, you read everything until you reach this, the closing single quote. And this plus is already here because this is just checking for the closing quotes.
Then what's the caret doing?
Yeah, I don't know what this is doing.
Because like if you're using regex syntax, traditional Perl style regex syntax, that's a negation, okay?
Mm-hmm. I remember that.
Which means it's looking for one or more characters which is not a single quote.
Mm. That is weird. That is weird. Isn't it?
It is kind of weird, yeah.
Okay, but we need to figure this one out. So how do we actually disallow to be empty? How do we actually disallow to be empty?
Maybe we should do this in the preprocessor actually.
Reasoning?
Um, if we do it here, okay, we do in fact disallow the declarations from using an empty name.
Mm-hmm.
As a side effect, we forbid the syntax sugar, the desugared version of the list syntax, right?
Mm-hmm.
Which is it's okay, I guess. But we also forbid any other functor with an empty name, including the empty atom.
Okay, that's not as good then. And I think the error messages will also suck, but maybe this is also because you're not dealing with main here properly. Maybe you can actually, yeah, maybe you can actually put better error messages. I don't know, I'm kind of okay with forbidding that, but maybe that's too limiting. I don't know. Well, let's do it in the preprocessor then, to allow people to just do what you mentioned. Um, okay, but then we're gonna have to do a map, right? After we remove the comments and before the grouping, we need to check if we have a declaration that is empty.
That has an empty name, yes.
Yeah. So let's do that. Map check empty heads. So let's go. Let check empty heads. And this is a function that takes a clause, but it's not really clear to me. Oh, this is a parser clause. Okay, so parser clause. And it should return another parser clause. Is the parser clause. Which means that we can do clause. Pretty much the same thing as this. But we don't care if you're a query, we just move forward. Yep. So other. But if you are declaration, we need to open you up and check if you are like this. Right? Maninho?
Yeah, yeah. Actually,
And if you are, we just do fail with you cannot have declarations with empty names.
yeah, that's pretty much it. And then that's it actually, right?
Oh, but there is a problem there. This pattern match values a type string, but a pattern was expecting to match this value. Do I need to use a guard for this?
Which values of type ast.func. Oh, because the head is not just a string, it's a functor actually. You need to check if the name of the functor in the head is empty.
Oh. Can I do that here? Does
You
that
should be able to do it in line, yes.
name_f equals this? Oh, awesome. Okay, so now you're forbidding that in the preprocessor level. In the future, we're probably gonna have some line and column information to pass. We're gonna have we're gonna have to make an entire error apparatus from scratch because we have none. Like we
We
literally
have
have a
none.
debugger, but we have no error messages. That's kind of hilarious. Um, okay, cool. But now we have a new problem, which is that this is now a parser clause, but this is failing. Oh, this is failing
Because
because it
that's
needs to be this.
supposed to be a list now, yeah.
Um, okay, let's actually run it to see. Oh, actually, let me also go back. Oh,
Actually, isn't that kind of backwards?
What do you mean?
Like, parser clause needs to have a list in the query, not the other way around.
Not the other way around. That's weird what you said, because my understanding is that we go from a parser clause to a clause.
Well, yes, but now the parser clause is going to be a list, right?
No, that's clause.
No. The parser is going to spit a list of functors as the query.
Um, yes. Yes. I believe to be the case. Yes.
Which means the parser clause needs to do a list of functors in the query case, right?
You mean here.
Yeah.
This seems very wrong though. Because look at the declaration case. The parser clause is the single and this is the multiple.
Because when we are in the parser, we just have individual declarations that may have the same name, but the preprocessor collects them together to make them easier to compile.
Ah, okay, but in this case, we are going from a list that is already being parsed as a list, and we're just going to another. We're just renaming it, essentially.
Basically.
Okay, so that means that this is also wrong. Let's do this. Did I save? I didn't. Okay, preprocessor. Line 15. Oh, I know what happened in there. The comment case is also now kind of fucked because you never have a query, you always have a list of them.
The comment case.
Yeah.
Hmm.
Yeah.
Well, in that case, we can just say, okay.
Can't we just call ourselves? Like, can't we just call remove comments?
Well,
I think we
if
should be
you
able to.
takes a parser clause, returns a parser clause option.
Yeah. Okay, so
If it's a,
this is gonna look like this. You do empty here, and in this one you grab the first and you call ourselves, and you map the new query to a declaration with empty things.
no. Oh, hmm. No, in that case, it's actually better to like call yourself recursively. If you get a none, you just remove it from the list of the query, right?
I'm I'm very confused. What do you mean by that?
Like you take the first item of the query, right?
Which I already forgot how to
Actually,
do, but I
actually,
think it's
actually, no. We
this.
have to do. Okay, no. Actually, the operation, if we think about it on a higher level, is you have a list of clauses for the query, right?
Yeah,
You have to map remove comments over that, and then
yeah.
you just keep the ones that are sum. The none get removed, basically.
We are already doing that. Like when we are doing a filter map. This is already removing automatically
No.
from the
But the
none.
filter map is for the top level elements. We need to do that inside of the query because the query is now a list.
Yeah, but that's a problem because this is being treated element by element. But now some of our elements are multiple. That's
Which
why
is why we need to do a map.
we're gonna be doing a map of what?
Remove comments.
What's gonna be the? Yeah, but you see that we're gonna have to convert the queries to something else
Why?
because they are just a bunch of funcs, right? We have a bunch of funcs in here. Agree?
They are, yes.
Okay. So let's say that I only have funcs. This function accepts parser clauses. What do I do?
Uh, okay, here's a suggestion then. We implement the single element case directly here.
Ah, okay. Now it makes sense. So you're proposing to make this case the base case, And then this is actually gonna be the mapped version. So we do queries.
Yeah, and actually for the empty case, we should probably return none instead of some.
You mean this?
Mm. Actually, should we? Should we?
I don't think we. I don't think no. Well, the program should not be allowed to reach. This should be a fail with actually. You should not be allowed to go to the go to this point in the program if you have no queries. What are you doing?
Maybe you're writing a library. A library wouldn't have a query.
Oh, but if that's the case, this should be a sum.
It could be a none as well.
Fine.
The question
So
is, which one is correct? Because they have different behavior, right?
they don't have different behavior, no, because we're just removing we're just removing this from it. Remember, if you are none, this is the point where you're being removed by the filter map. So what harm does it do removing an empty query? First of all, you should not be able to construct this, but you don't have a dependency type language.
I mean, there's a way to make a non-empty list type, but it's kind of inconvenient.
Yeah. Okay, so what we're gonna do? We're gonna do a lambda here, and we're gonna pass. Actually, I can just call this queries and do queries here. And then the function, we have
Is going.
individual funcs, so we need to create singletons. So this is fun query, and then we do remove comments at ast query that.
And then we have to do one more step. We need to remove all of the. Isn't there a function somewhere that we're using that takes a list of maybes and turns into a list?
We're using something like that, yeah.
Yeah, we need that basically.
I think we're using this in the parser, no? Concat map, option to list.
There we go.
Uh, okay, this is incorrect. I need to do annoying. I need to do query this nonsense, but I need to filter out the nonsense. Okay, so let's actually filtered queries that in, and then we do some query. Oops. Filtered queries.
But we also need to unwrap the queries, right?
What do you mean unwrap them?
Because we took the functors and wrapped them into singleton queries, so we could
You're
do the
right.
recursive call. So we need to undo that, actually.
That sucks. That's success. Okay, let's actually make that in here. So filtered queries. Then we do fun query func, and this should be this. Then we fun
Then we
func
do the concat.
funcs. No, then you do. No, you're right. Then we do this thing.
Actually, we need to do the concat map first,
First.
and then we unwrap everything.
Yeah. So you do that, then we have funcs, and then out of the funcs we create the funcs. Right. Okay, so the first thing we do, we call ourselves recursively to remove the commented queries. We grab that response, we remove the maybes, the nones, sorry.
Yeah.
But I wonder. Yeah, no, this is right. Then we. Oh wait, this is already a func list. Ah, because this is a singleton. So I need to also to extract this. Yep. And then we have the sum. This should go there. Thoughts? Ugly as fuck, huh?
There is a small corner case where the query may be empty at the end.
That makes sense. So if do we have list is empty, empty, funcs. If it's empty, this should be a sum, a none, else sum, right?
Yeah.
And it looks
Yeah.
ugly, but it could be worse. Okay, so we removed the empty heads. Let's test this out. We should fail now. Oh, it's not compiling. So registry allocator, the registry allocator is broken. What is the line? 61. There we go. Wait, 61?
No, it's the parser actually.
Oh yeah, it's the parser. The 149 is failing. Unbound constructor.
Register allocator.
61. Wait, why is this wrong?
You're missing an N. It's a typo. I don't think we need this case though.
What do you mean?
Like, the second case is a superset of this one.
But this is a non-empty list.
And the other one is a singleton, which is a non-empty list.
Let's try it out. Okay, but this is not compiling. Let's make it compile. We need to test this out with a previous example. Okay, so 149. 149, there we go. Query conjunction, allocate query. Okay.
This expression has type func list, but it was expected to be an AST func. Right, because you just changed the type, so it's a list now, yeah.
Yeah, but now I have a question. Should we concat all the elements? Because you only care about the elements.
What do you mean?
We have list of each query, each func has a list of elements, agree? Now we have a list of those. It has?
Allocate query is an allocate loop of list elements.
Yeah, this is the difference. This is now in plural. So this is now a list of funcs in here. But what I'm proposing is, can't we just concat all the elements and call it a day?
No, we can't. We have to change this substantially, actually.
I'm surprised, why?
What we need to do, actually, technically you can keep this allocate query as it is, but it's not going to be directly called in the query conjunction. What we need to do is, we need to find all the variables in the query arguments, right?
Why?
Then we need,
I'm so confused.
because we need to desugar the conjunction lemmas.
Oh, we're gonna do this on the register allocator level?
On the register allocator level.
My understanding was that we should be doing this in here.
Actually, no, we should be doing the desugaring in the preprocessor actually. We need to add another pass.
Yeah. But that begs the question. I think this is now wrong then. This should not be this. This should be
No, this
already
should
the. This is the
no
output
the
of the preprocessor.
yeah, the query conjunction should just be a functor. It should be as it was basically.
Exactly. Exactly. Okay, so that was my bad. Okay, now the preprocessor is failing now. Preprocessor. It's failing exactly. Yeah, this is the place. This is the place that we need to do the desugaring, right? So these are
It is,
funcs.
yeah. Yes.
These are funcs. So okay, so what's the first thing that we should do? What is the first one we should do?
We okay. We need to first collect all the variables in the queries, right?
uh, okay, there is a slight problem.
Okay.
The desugaring strategy that I proposed does two things. It not only does one thing. It creates this query, but it creates this declaration.
Yes, we need to do that.
Yeah, but that's not what this function does. This
Oh, this
function
is
does a
one-to-one,
one-to-one
right?
mapping.
Hmm.
Fuck me.
Well, what we could do is make this function return a list. The declaration case just returns a singleton. The query returns two things.
I don't like that because that will mess up with the. This is already being used in here.
No, we can just use we can just replace the multi-mapper map from declaration. Yeah, basically all the maps would need to become concat maps instead.
Wait, repeat. Sorry, I got distracted.
Yeah, basically we replace this, we change the signature over there to return a list, and then everywhere that calls this thing with a map, we would have to use the concat map instead.
Man, that's going. Yeah, but this is gonna completely bust this. Oh, concat map. Okay. So you make this a list. This becomes a singleton. Actually, maybe. And this is a concat map. And parser to compiler returns a list which has these as singleton. Now we can do the thing. So let's make first the declaration. I think that's easier, no?
And the declaration is the one actually that needs to do. Well, actually, both of them need this, right? The variable collection, basically.
Yeah, when you say variable collection, what exactly do you mean? We have a bunch of funcs.
We need to find all the variables in the arguments of the funcs, no matter how deeply nested they may be.
Wait a moment, man. People are talking to me and this seems important. Fuck. Uh, okay, it is important, but it can wait a little bit. Okay, could you repeat the last part, Marinho? Sorry.
We need to collect all of the variables in the arguments of the funcs, no matter how deeply nested they may be.
Why do we need that? Oh, because we need to put them on the top, on the head
They
of the
will,
declaration.
yeah, they
Fuck
will
me.
become the arguments of our declaration
Yep,
and
yep,
also
yep.
the arguments of the query.
Yep. Okay, so let's look at the func. So a func has this thing. This sounds annoying.
Yeah, no, we need to implement some tree walking, basically.
But we did this before. We already did this for printing.
Well, we can move that to... but for printing, we are assuming that we already ran the preprocessor, right?
Oh, actually, I lied. It is not that hard. Because a func, we can always ignore the name, because the name is always not a variable. We need to iterate over the elements of each one of them, and then concat map with variable case being the sum and everything else being the none. Filter map, essentially.
Not quite.
Oh, sorry. There's also the case that we have a nested functor with another func in there. But if that's the case, we just call ourselves recursively.
That's a thing, yes, but that's not what I was thinking of.
Go for it.
You may have multiple variables in the same functor.
What's the problem with that?
That means you can't use a maybe, you actually have to use a list.
It's already a list. It's a list of expressions.
No. I mean, when you do the mapping, instead of using a maybe as the return type for the function in the concat map.
Okay, let's start writing some prototypes because I think that's. Let's make a function called find variables, and what you're gonna receive is a func, which we're gonna already destruct anyway. So this is gonna be ast func. What should this return?
It should return a list of variables.
Okay, so this should return ast variable, well, xpr list.
You can just make it return a list of strings and then we can turn them into variables later. That's also an option.
That works. Okay, so let's match on the elements. If we have nothing, we just return nothing. If we have a singleton, we have only one element on the functor. We need to check if what is it, right? Because it may be. So if it's a variable with a var, this is the singleton case. So var. If it's a functor with another func in here, elements, more elements, we need to figure out what we need to do. If it's anything else, I think we should call ourselves recursively.
If it's anything else, yeah.
So es, we need to call ourselves wait, but this takes already all the elements. It doesn't take an element per element, right?
Right, this takes an entire functor, yeah. This doesn't quite work in the recursive case, actually.
Yeah. So I think we should just get expression.
Just make find variables take an expression. That's better.
xpr. So this is not necessary. This is that. This is that. This is that. And then if it's anything else, it should just be a failed actually.
Why?
Because if you are not a variable or a functor, you are an integer.
Then you return an empty list.
You are right. You are completely right. So what is the problem here? Wait, variable of var. What the fuck is a var? Oh, there is name v. Okay. Okay, I think this is good enough. So now what do we do in the case of functor?
Oh wait, we can return. We actually have a separate type for variables, don't we?
Yeah, we have a var, which is the var.
We can just return that instead of a list of that instead of a list of strings. That's probably better.
Sure. Okay, so in the case of that we have another functor, we need to do a concat map on it, no?
Concat map, we find variables on the elements.
concat map, more elements, and the function is find variables. That's it, right?
That's it.
Okay, but now we need a case that goes through this. Well, we're gonna do a concat map using these on the funcs in here.
Basically, yeah.
Okay, so we need to. Okay, so let's do let variables list concat map funcs, and what we're gonna be
Find
doing
variables.
is um, elements.
No, it's just find variables.
Nope. And then we need to do list map find variables on the elements in. There you go. Unbound record field unused. What do you mean? Do you want the type here, maybe? Func.
No.
Oh, you do. That was weird.
Huh.
Okay, this is it, right? Now we have all the variables.
We should have all the variables, yes.
The order doesn't matter. We don't need to sort them, right? My understanding that this doesn't matter. The order.
The order doesn't matter, no. We do want to remove duplicates, though.
So this should not be
We should actually make it
a
return
set.
a
This should
set
be a
instead of a
set
list.
instead of.
Yeah.
Yeah, I wonder if the set should be from the start.
No,
Why?
because the
Why are
order
you using
matters in the
lists?
query. Because the
Why?
order matters in the query. Because
Why?
Prolog defines the order in which you should call the predicates.
Ah. Okay.
Like
So.
Prolog, the problem is Prolog does strictly depth first search, right? Which means you have to call the predicates in the order that they appear in the source code when you're doing a conjunction.
Okay, wait a moment. So where are we using this? We're already using a set before. I just don't remember where. Where are we using a set? Do you remember?
Probably the register allocator. Maybe the code gen as well.
Oh, there we go. Bat set. Maybe the code gen as well. Yeah, this is how you do it. Cool. So let's put that in here. Variable set,
That's
exactly.
that's an AST.var, yeah.
There we go. I actually don't think this is necessary. And then this is just
A variable set.
a variable set. But now this is wrong, right? This is wrong. Okay, that's why the module s was there, was to make this easier. Oops. Module s equals bet set. There we go. And now we need to do operations on it, which I also have no recollection of doing at all before. Empty, find opt. How do I put stuff in it? Add. Thank you. So here we're gonna do
s.add
s
var
add
to the empty set.
s empty.
That's backwards. The
No, it's
element
not
comes
s.
first.
And then there. Yeah, but then the concat map is also gonna be fucked. Do you have concat map on set? I don't think we are using 3.5, but I don't think that matters.
I
Set.
mean, function composition is bleeding edge.
I hope they have it, because otherwise it's gonna be embarrassing. Wait. Yeah, that's gonna be embarrassing.
Worst case scenario, we can do a fold.
They have a union. No, but they should have a map endo. That's not filter map endo. I don't think they have it. I think they expect you to do the fold. Why? Why?
There is map. There is map. Does that help?
No. Well, no, because we need the fold and the map combined. That's what concat map is. They don't have it. They expect you to do the fold yourself. Fine. OCaml people. OCaml people. Um. So what? So this is gonna be S fold. Um. We actually I lied. This is actually a least fold left. We're gonna fold over the elements, and the accumulator should be the empty thing. I forgot. What is the order? The accumulator comes first, so ACC element.
Doesn't matter actually because we're going to just do set union and that's commutative.
As union ACC find variables on the element.
Oh right, you're actually doing the operation inside of the fold, I see.
And this. Okay. That. Man, there should be a way to remove this lambda. But I'm too tired to figure that out right now.
Well, you can do a map and then do a fold with just the set union.
Nah. Nah. This is good enough. Okay, so this means that what is the output of this? This is a list of variable sets.
We need to do
Another
wait.
union. We need to do another concat map.
Wait. We have a query of functors, which are the members of the conjunction. We're doing a concat map
Yeah.
over them.
Yeah, this should not be a concat map. This should be a fold. Same thing as above. And then the ACC comes here. Parentheses somewhere. Wait, I'm doing something wrong. And this should be something like that. Man, this is very, very terrible. Folder. So this is set, and this is the element. Let's make this by pieces because it's getting unhinged. So we grab that, put it in here. Maybe it is the fucking parentheses. And this is the set.
That returns a list and you're trying to do a set union.
S. I'm assuming this is a thing.
Dude, you can ditch the map if you just wrap the element inside of... Or rather, if you just take the entire functor, wrap it in an ast.functor, and just do the find variables in it.
I'm very confused. This is a list of expressions. I need to map it over it, no?
You can, but find variables already does that.
No, it grabs a single element.
Which can be a functor.
Okay, so I see. I see what you're saying. Ah, that's essentially the same thing, but I will do that to please you.
It saves you from having to call the from list explicitly.
Uh, but I'm gonna have to make a func with a.
No, 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 no. You already have a func. Just stop
Ah,
destructuring it.
don't destructure it. Just say func there and func here.
Yeah, get rid of the from list. You don't need it anymore.
We do. This
We
is the
don't.
folder. No, we do. This is the
We
folder, which
don't.
means
You're doing a set union with a list, Lemus. Or rather, with a set that you're trying to construct from a list, which is actually a
no,
set.
this is already returning to me the thing. That's what you mean.
Yeah,
Ah,
there we
finally.
go.
Now this is a variable set. Yeah. Cool. Cool, 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 cool. Wait, but you just said that the order matters. Why did we do this?
The order matters for the body of the query. For the order of the arguments of the query predicates, we actually don't care about the order. As long as it's consistent in the head of the definition and also in the actual query call, right?
What is a declaration? It's a head and a body. So let's start from the head. The head needs to be a func. So let's do that. A func, it's a nameF, which is gonna be empty. Let's not here do that, I guess. Yep. It needs to have, well, it has a tag. Is the tag? Yeah, an alias for string. And then we have the elements, which should be.
Yeah, I think we should actually do a set to list on the variables because we're going to need to use it twice, and we also need to count how many elements there are. Is there a function to take the number of elements from the set, though?
If that doesn't exist, this is a joke.
There should be one. Like, search for size, search for count, search for length, maybe?
All of them. Okay, this is getting close to being a joke. Diff. No, 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 no. Yes,
Cardinal.
cardinal. Okay. I was worried a little bit there. S. We're not gonna use it anyway, so it doesn't matter. Um.
I
Okay,
mean,
so this is variables, and the arity
then it's just the length of the elements.
least.
Which is kinda why I wanted the cardinal function, because I imagine that's constant time.
Oh, I see what you're saying. You prefer this as.
Yeah, basically.
There we go. Okay, that's the head. Um, what about the body?
Actually, we do need to do a to list in a let because we're going to need the list of arguments again when we're constructing the actual query.
That's true. Least. Oops.
F dot to
All,
list.
all because the constant time. Oh man, it wouldn't be Marinho if that was not there.
I mean, you gotta use whatever natural operations you have, right?
Okay, the body. The body is a func list. So this is just funcs.
It is.
And there we go. But this needs to be a multi-declaration shit. So this should be multi-declaration, and then
This is a little.
parentheses declaration. This is the first one, and then the other one is empty.
That's not how that works, Lemus.
Wait, what? It's literally written in here. It's exactly how it works. I just don't understand what's the problem there. Multi-declaration. And this needs to be a list.
Hmm.
Oh no, but we're gonna construct the list at the end. Doesn't matter. Okay, now let's make the query. So this is gonna be a fail with blah blah in, and the output of this will be declaration query.
And query.
Yeah, I don't understand what the fuck is wrong with this. I really don't understand. Multi-declaration. This is a tuple. Is this LSP going insane? Yeah. Okay, doesn't matter. Let's do the query now. So what's the query? A query needs to be a query conjunction. Wait. Query conjunction.
Well,
This is
technically,
bad naming.
we can just call it query, but that's going to conflict with the other one.
This should be conjunction. And this should be query.
You're missing an N down there, by the way.
I don't know why I keep missing that in every time. Right? This is right now.
Yeah, that's better.
And that's gonna break everywhere, but I don't care. Okay, so we need to return. This is a query conjunction now. Conjunction. And
You're missing an N.
missing an N, of course I am. Let's actually go over the compilation errors because I think this is gonna break before reaching there. Yeah, line 15. So all of these are conjunctions. And the same applies to this and to this.
You're missing N's up there as well.
I don't know why this duplicated, but there we go. What else? Registrar locator 149.
The registrar locator is easy. You just get rid of all the conjunctions, right?
Yeah. Replace string con. I probably typed this.
You're missing the N. You're missing the N.
Only one place. Code generator.
Same thing.
Same thing. Compiler.
Same thing.
Preprocessor 52. I think we're back where we were supposed to be. Yep.
Nice.
Okay, so now we need to make a query. So how do you make a query? Let's see. So a query is just a func.
Well, yeah, we just make a func with an empty name and the same list of variables that we used as the head of the declaration. As the arguments of the head of the declaration.
Func.
Actually, we can probably just abstract that func, just give it a name because it's the same func that's up there in the head as well.
That is fair. So name.
Actually, take the entire head. That's better.
You mean this?
Yeah.
Head. In. This is a func. Well, actually, NAST func. List var. Oh, we need to map over this. Fun var. Thank you, OCaml, for not making. And
The
this is
query is
just the
just
head.
no. You need to wrap it in a query.
Something's wrong. Compiler. Unbound constructor. Man,
Oh, you need
am
to do
I
AS,
smoking?
AST dots probably.
I don't think that was necessary because on line 46 I'm not doing that. But sure. Ah, I know what's the problem. A declaration is an anonymous record. I was smoking the fact that this was here. No, this is still required. Yeah, that doesn't make any sense. But whatever it takes. This expression has type A, B, but an instruction is expected to have type A clause. What?
Hmm.
What? What are the available clauses? Multi-declaration query. This is a clause, and this is a clause. This is a list of clauses. What are we doing? Do you see a problem?
I don't, to be honest.
This is not how you do that. And of course. Off the fucking course. Are we done? Are we done?
We should be actually.
There's no way. Okay, let's look at the example again. Let's actually go back. Yeah, so this program should run.
Yep.
No.
Hmm.
Okay,
That's
so
weird.
whatever it is doing something very wrong. Whatever it is doing something very wrong. Okay, so now let's look at it.
Can
How?
we print the output of the preprocessor?
Um, yeah, but that needs to go over here. Yeah, we need to go. Actually, no, this needs to be here.
We can just print the first argument of the compiler. That's equivalent, right?
We can. Yeah, right here. Print and line. Printing in OCaml. I wanna die.
That doesn't quite work because compile is recursive.
That doesn't matter. There is a way to speed this thing up, which is to put this here. Okay, so
Show
show
farm.
clause, show clause form. There.
Hmm.
Wait, we're not reaching this.
It's looping.
It's looping over what?
Not reaching the 2.
So compare. Wait, we're not reaching the true.
Oh, but that's in multi-mapper. That's the last thing we do.
Yeah, I know, but let's go to remove comments. Oops. Where is my... Yeah, here. Let's put the true over here. Okay. This guy is phenomenally failing. I wonder how. I actually wonder how. Okay. It isn't here.
Wait a second. Filtered queries. Remove comments from the query conjunction. Query.
We're doing something phenomenally stupid.
Oh, we're missing a base case, Lemos. That's a problem.
But we have two base cases.
We need a third one.
Which is?
The singleton, which is not a comment.
Um, but that's just some.
Yeah. Some query, and it needs to be actually...
This is a func, and this is expecting a parser clause. So this needs to
Yeah,
be a query
just
conjunction.
the query conjunction as whatever, and just return it.
Exactly.
There we go.
Yeah, I... what happens if we... Yeah,
that
segmentation
fails.
fault. I want to test something else. I want to test what happens if I swap...
That should break.
Error
Yeah.
message is kind of meh. Cannot.
With an empty name.
Query.
Name. Names in plural, it should be singular.
That's true.
Can
we
we
have
do...
it? What the
Oh,
fuck?
can we
This was
do...
surprisingly easier than I
Oh, one
thought.
more thing, Lemos, just for the sake of completeness. Can we rename that for in the plus to a variable? Like, replace the for with a variable, just to see that we're actually grabbing all the variables, right?
You mean like first?
Yeah, that should give us a for, and it does.
Awesome.
Oh, also, just to be funny, replace the -2 with another variable.
Second. Doesn't work.
Okay, that fails. Yeah, no, that fails. That fails because...
For actually, that's kind of weird. Should it be able to figure this one out? Let's think.
No, because negation would have to guess a number.
Ah, we don't have that implemented.
Yeah, never mind
We
then.
should put that in the README. Like very low, like lowest possible priority in the universe. Compiler generates literals for
numeric primitives.
Not only numeric, right? Like this is like data creation. I'm just gonna keep it like that because you should also be able to create a functor, I guess,
But
which is a
that works.
literal, but that's
Well,
not
yes,
a
but
number.
that kind of works because like all of the primitives that deal with functors, they kind of know how to handle variables. It's just the
Hmm.
numeric ones that don't in general. There are some
Let
cases where they
let's try to
can't.
exhaust this example. Like, can we make a similar example to what we were attempting, but one that it is reachable without having to create a number?
You can just call minus a second time with three variables. Or rather, with two variables, right?
Okay, so you're saying minus, and what do I put in here?
Um, let's do first, second, and out.
No,
That doesn't work either, huh?
but that should work. No? Oh, wait. I don't. Well, but I don't think that matters. Yeah.
It doesn't. Hmm.
This seems like we have a problem.
Yeah, because at this point, first and out should both be bound, but minus on the second. Oh, it's because the second is unbound, and that's the first thing we do. That's kind of silly.
Okay, so how do we? Okay, so this is behaving correctly then. It should segfault.
Go to the definition of minus and flip the clauses in the body. Oh, that also is not gonna. No, that should work actually. Yeah,
No.
it doesn't. Huh.
No, 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 no. No, no. No, no, no.
Yeah, that's kind of sad.
Wait, but is
Um,
this a problem in the compiler or is this semantics of Prolog?
that's the semantics because you see, the problem is, well, it could be a problem in the compiler actually. It's possible, but
Can't you
there's,
just go with your Prolog in the repo there and test this out?
I guess I can. Let's
Yeah,
see.
let's see if we are daydreaming here.
I just need to remember how do I do addition, but let's see. Minus, oops, minus ABC is the same as um, ABC is the same as C is A minus B. Right, that's essentially what we're doing. Operator expected here. Oh, right, because this is Prolog, we use parentheses, not square brackets. Oh, and of course, we actually have to put the rules in a file, because why would we be able to add definitions in the repo? Karuta, temp.pl. Oh, we already have a temp file. Okay, that's convenient. Minus A, B, C. C is A minus B dot, and then the query goes in the repo. The query goes in the repo. 3pl dash f temp, and then I do minus a 4 minus 2 out, then minus 4 a out. Let's do the plus as well. Yeah, out is first plus 2 and minus first second out. This should work, and it doesn't. Arguments are not sufficiently instantiated. Yeah, that's the
Oh,
problem.
so that's Prolog can't do it.
Prolog cannot do it for the same reason, I'm guessing, that we cannot. It's just Prolog. SweepL has a nicer way to handle this.
Okay, so well, we don't have error messages, so what are you expecting? So can we do this?
Let's see. The first is 4. The out is 2.
Actually, this.
No, the out is 6. No.
4. Oh yeah, no, you're right. The out is 6, so this should be
So
minus.
minus 2. That should work,
Nope.
I think.
Nope.
Minus first out minus 2. First out minus 2. That actually, yeah, arguments are not sufficiently instantiated either. Let me think for a second. What if... Okay, let's remove the third call. Arguments are not... Yeah, Actually, Prolog cannot do that case either. Let's... Just for the sake of completeness, A, B, C... C is A plus B.
Swapping these two fixes it.
Okay.
Is that expected? I'm not a professional logic programmer, so.
In this case, it is actually no, because let's see. The in is defined, the out isn't, because that's going to be defined by the negation later. And the out is minus 2. And the out is first out minus 2. Out is first plus 2. And then minus first out minus 2. That doesn't work in Prolog, oddly
This
enough.
doesn't work.
That's kind of interesting. What's happening? First and out should both be defined when we do the plus. Because out is defined by the first minus. Then plus fills in the first. And then minus. That's kind of weird, if I'm being honest. But it doesn't seem to be a problem specific to our implementation, so it's probably okay.
No,
I'll have
but
to look into
we are
this.
doing something that Prolog can't do. This code swapping for parentheses doesn't work in Prolog.
Yeah, that's funny. That's weird.
That's okay, but that leads me to believe that either we are getting it by accident, just like a coincidence that the output is correct, or I don't know. I refuse to believe this is more powerful than Prolog.
First to out. Yeah, arguments are not sufficiently instantiated.
You were rewriting this with the desugared version, right? I know what could be. We need to make a print. We need to make a print. Yeah, we need to see if if the compiler, if the preprocessor is reordering the things unintentionally, and that is causing a side effect of being able to unify. But if the order was proper, we would also segfault.
That's a fair
There we go.
point.
There we fucking go. So this is the query that we are creating.
Actually, the query doesn't matter because all the arguments will be variables,
Oh, we need to
regardless.
check the declaration that we're creating. My bad.
We need to check the new declaration, yes.
So let's go to the preprocessor. And in here, we're going to just say declaration. There.
Minus plus minus. Yeah, no, it's the same order.
Okay, now I am out of ideas. This doesn't make any sense. I refuse to believe. Magetta, are you back?
Yeah. Let me see.
Magetta, look at this miracle. So look at this program right now and make your bet. Should this unify or not?
Wait. Let me see. So
Ignore Karuta. Think in Prolog terms. Think with your beautiful brain. Should this unify?
I'm pretty sure this is a trick you're playing on me. Give me a sec.
Well, there is a problem, but you're gonna be surprised on the problem.
Let me think. Give me a sec.
Yeah, Marinho, don't say the answer.
Okay.
Huh. What happens with the... I think this is logically valid.
Okay, so do you want the answer?
So it should be like first is like 4, of course,
Yes?
and the out is 6, I guess.
Yes. So here's the deal. In Karuta, this works, but in Prolog, it doesn't.
I don't think Prolog. Well, have you implemented them plus and minus in Prolog? Maybe that's the problem.
Marinho?
Because
Here's what I'm doing in Prolog. And you can tell me if I messed something up. Because syntax, right?
I don't see a reason why you shouldn't.
No, just for the... Okay, so here's the answer. You're right.
Okay.
But this...
And I'm running this in SweepL, by the way, if that matters.
Yeah, so
Yeah.
what is Marinho... okay, let me put this on the screen as well. I'm gonna copy your program. Okay, so here's what Marinho is writing. And why is it doing like this? Because in Karuta...
Oh, you're doing with arithmetic. That I don't think that work. With the C is blah blah. I don't think that it cannot it cannot unify definitions of variables like that.
So how should
You
we
need to-
rewrite this to make this happen?
Good question. Wait, you can do that if you implement the negation and the plus in another way. Oh, but they're primitives, right?
Yeah, our negation and plus are primitives.
So you need to change.
And I should mention something.
some-
This program doesn't work in Karuta if I swap these two clauses.
Swap these two clauses. So if
Yeah.
you put the plus before
Yes.
the negation.
Then it can't unify. Let me just demonstrate that.
That is weird. Why? Because it constrains first the minus. Are you running minus? No.
Oh, I
plus?
know. Actually, I know why this failed. It's because of the first minus, not the second.
Wait, you're talking about the swapping the order, Marinho?
Yeah, because of the first minus, wait, no, but the first minus is taking a -2. Oh, that doesn't matter. You see, the problem is if you swap the order,
Mm-hmm.
And the first minus, the out is undefined, it's fresh, right?
Yes.
That means we're calling plus with two unbound variables, and that doesn't work.
Ah, okay, so that solves one mystery. Did you get it, Magita?
Wasn't paying attention. Sorry. What?
If you swap the plus with the negation,
Yeah.
the out would be depending on two.
The plus is going to be
Yeah.
called with two unbound variables, and we haven't implemented that because that's non-trivial.
Yeah, so here's the situation. If you
Oh, I
do
see.
this
I see.
order, this is defined and this is defined, so this can be
Yeah,
defined.
I see.
Then the
I see.
plus
There are
is
two
happy.
that are not. Yeah, yeah.
Exactly, exactly. Okay, so we solved one mystery. We need to solve the mystery on why the prologue version doesn't work. I refuse to believe this is more powerful than prologue.
Well, the prologue doesn't work because you cannot unify C is A minus B. You need to use the unification arithmetic predicates to be able to do that.
Do you know how to
I
do
did.
that?
I remember doing this with the kids, but it was weird. Let me see. Let me find the thing. Unify prologue some predicate. Yeah, here. There's a predicate called sum.
Oh, sum.
That will likely work. Let me see. It's inside of a module called. You need this module here, Marinho. I like the import system in Prolog. It's very simple.
We're gonna implement next. That's our next feature.
Are you going to do a Harper compliant module system?
No.
Then it's a toy module system.
I agree, but it's gonna.
Is Prolog's module system Harper compiled compliant?
Well, it doesn't. It doesn't. Man, it's literally just. Don't know actually because it's a. No, it's not. It's
Yeah,
not.
it's not. Yeah, we're gonna do prologues.
It needs to have. It needs to have like a signature that you can replace, like OCaml, more or less.
Yeah, but that's literally our next feature. If you get on the README, today we're gonna finish this, then we're gonna do that, which I'm calling namespacing here, and
That
then we
would
are
be
done with the
interesting.
language level things.
That would be very interesting if you guys can pull this off. Because I think it's like most languages don't get that right. If I
No, no,
can
no.
count
We're
on
not
my
gonna
fingers.
do. We're not gonna do Harper compliant
Ah,
module.
then what's the point?
Ah! Then what's the point?
What's the point of even doing it, right? There's no minus, but I think you can use just a sum with negative integers, Marinho.
Sum.
Oh,
And
why you need the
a
module
bit
system? Because we
strange.
want to make a math Karuta library which has minus.
By the way, it's a bit strange how this works. It's like this.
This what? Oh, the prologue.
Yeah.
Okay, let me just try this.
Oh, in the meantime, I'm gonna remove the print from the compiler. Where am I printing it? Oh, I already removed it. Wow, this was surprisingly not that difficult to pull it off. Awesome. I told you,
Okay,
Mario,
now
we already
this.
have this. Go on.
Okay, now this works actually.
4 and 6?
Yeah, I get 4 and 6 now.
Yeah,
Awesome.
because the C when you do C what something is blah blah blah, you're like defining a variable, but that variable is not being unified. It's just like an assignment.
Ah, that's the problem.
Okay, so
Yeah, this works.
okay, okay, but I think we're done. No? What are we lacking here, Maria?
By the way, in terms of ergonomics, your trash is better than Prolog in that way.
Thank you. Thank you very
You don't need
much,
library.
gentlemen.
Right?
No, yeah, we after we have namespace implementation, we're gonna have like be able to create like a lot of useful predicates. Like we can have a lists library already. We have all of these for lists. Like we have partition, we have reverse, we have add, we have append. We can already have a lists.karuta. Marinho, please tell me if we're done or not.
I'm pretty sure we are. There's just one small detail actually.
Go for it.
Right now, we are forbidding the declaration of empty named predicates, right?
Yeah,
In the preprocessor specifically.
yeah.
But we aren't forbidding two query declarations on a file.
Is that even possible? The parser will allow that?
The parser will allow it, but it doesn't work.
There it is.
Multiple queries are not supported yet.
Actually, this error message is wrong then. Multiple, yeah. Multiple queries are only supported via via the comma. How you say
Syntax.
the using.
I have a question. So if I send a XML for this, and suppose that you guys have a parser for XML through lists, let's say, how would Karuta deal with lists right now?
The way that it works right now is the following. Lists in Karuta are essentially a syntax sugar for a particular functor. So this, where is it? Oh, we deleted. But this query, for example, this is a list that has one-to-one
With the
elements.
empty operator and cons, right? I remember.
Exactly. Exactly. So this is we are essentially after the sugar is all over, this is what we have as a functor with arity true, and we have special treatment for this functor inside the compiler. That if your name is empty and your arity is true, you are a list, in fact, and you follow the semantics of lists. So if I write this, for example, instead of writing the more readable version.
Yeah, technically it is not fully desugared because you don't have the explicit empty name for the empty list as well.
What do you mean?
Like, you're still using the sugar syntax for the empty list, but that should be just the empty atom.
Oh, you mean this?
Yeah.
Okay. Yeah, Marinho is right on that detail. But answering Mageta's question, lists in our stuff, they are essentially syntax sugar for functors. So
With an empty name, yeah.
with an empty name. That's what they are.
Interesting. So because I was thinking I can.
Well, I should say an asterisk on that. They are functors, but the special treatment that we give them inside the compiler generates different code for them. So they don't use the same codes.
I see.
Yeah, we have special codes because since lists are very common, actually there's a small improvement we can do on that, but we can talk about that later.
Yeah, so when we have functors, we use these two, for example, but if you are special, we use these two instead.
So I have another question. How excited are you today, Lemus?
I'm just excited as always. I'm very happy, actually. We finished conjunction in one day. I couldn't be happier.
Would you be excited to stay 2 more hours here?
Sure. Sure. Let me finish the recording for conjunction. We are done with conjunction, right?
Yeah, we are.
Okay, so let me just make a commit here, Mageta. Then you can.
Okay. Let me go to the bathroom and I have an interesting proposal.
Okay, so I'm gonna mark conjunction as done. There we go. Okay. Surprisingly easy, huh?
That's the power of macros. Although we don't have user-defined macros, but this is essentially a macro that we implemented.
Yeah, but not having user-defined macros is a good thing. that.
To be fair, I'm not actually a big fan of macros, if I'm being honest.
Yeah, you always.
That coming from you is very
Exactly,
weird.
exactly. That always sounds weird because of your. Well, but you have solid arguments against it, so I'm fine. Man, we didn't have to
Yeah,
change anything below preprocessor. Code generator. Well, we had to touch the code generator because we renamed it to a better name, but we didn't have to touch register allocator practically, code generator and evaluator. Everything just works because of the syntax sugar. So
yeah,
add.
it's everything is nicer and easier to do when you know how to map things to other equivalent things.
Yeah, that's why it kind of feels like cheating a little bit. uh, well, okay. Now we are one feature away from now just doing database. Following the plan.
So if I give you an XML, Lemos, with elements,
Oh, let me stop the recording now.